This video will demonstrate how to use the Vernier Go Direct colorimeter in order to determine at which of the 4 preset wavelengths does your solution have a maximum absorbance value. The items we will need are the Vernier LabQuest 3 and its corresponding power cable. We will need the Vernier Go Direct colorimeter and its corresponding cable to connect to the LabQuest 3. We will need 2 plastic cuvettes, some deionized water, our colored solution, and paper and something to write with to record our results. So to start, I will connect the LabQuest 3 to the power outlet. I have plugged it in to the power outlet, and next I will connect the other end of that cable to the top of the instrument. Now I will push the button to power it on. Next, I will connect the colorimeter. So from the back of the instrument, I can connect the smaller end of the cable. And through USB, it can connect to the LabQuest 3 on the side. The LabQuest 3 should automatically detect that the colorimeter has been connected. If it hasn't, you can click the home icon and enter the LabQuest app. So currently it's displaying that at a wavelength of 430 nanometers, that is the preset option selected, the current absorbance reading has a value of 0.13. So what we need to do next, we need to calibrate the colorimeter at the particular wavelength that we are interested in measuring first. So we'll take one of the cuvettes and fill it about 3/4 of the way full with our deionized water. I'm going to tap it gently on the bench top to be sure there's no bubbles. Next, I will open the top chamber of the colorimeter by simply sliding this to the right. And if you notice, only one direction through the cuvette is it completely clear. That clear direction needs to be aligned with the light source and the detector. So I have the clear side, it's being entered this way to the chamber. I'm going to close the lid and push the CAL button to calibrate the instrument. You'll see this light will blink. Once it is done calibrating, the light will stop blinking and you should see an absorbance reading of 0. Next, I'm going to fill our second cuvette with our sample. Again, about 3/4 of the way full. Again, I will tap to be sure there are no air bubbles inside. I'll remove the blank and insert our sample, again being sure that the clear direction is aligned with the light source and detector. So at this wavelength of 430 nanometers, I'll wait a moment for the absorbance to stabilize. The absorbance at this wavelength is 0.75. I will note that here. So at 430 nanometers, absorbance is 0.75. Next, we'll repeat this, but for the other wavelengths. So I will remove the sample, and next I will use the arrow button to go to the next wavelength, which is 470 nanometers. Again, I'm going to insert the blank and calibrate. It has stopped blinking. I will remove the blank and place the sample. I'll wait for the absorbance to stabilize. I'll record the absorbance at this wavelength to be 1.42. Next, I'll remove the sample and move on to the next wavelength, which is 565 nanometers. I'll insert the blank and calibrate. Next, I will insert the sample. I'll wait for the absorbance to stabilize. It has at a value of 0.29. And now for the last wavelength. We'll calibrate. Now insert the sample. So at this wavelength of 635 nanometers, the absorbance has a value of 0. So I will note that your absorbance values are likely to be different than these. All we are looking for here, though, is to see at which wavelength did we have the maximum absorbance. And for my sample, the highest value here was the absorbance of 1.42 at this wavelength of 470 nanometers. So to take other measurements with this particular type of solution, I will need to consistently use the 470 nanometer wavelength.